Ladies and gentlemen, good morning and welcome to this new class. Um, for those who have subscribed to our channel, thank you very much for supporting us, and please, that subscription button, click on it, ring that bell so that every time I upload new videos within networking, then you're sure that you'll be part and parcel of this family. And we are doing very good videos. We are doing the whole of CCNA. We've done CCNA 1, CCNA 2, and now we are doing CCNA 3. And when we are done with CCNA 3, we're going to be doing CCNP. We'll do cyber ops, we'll do network security, we'll do DevNet associate, we'll do a course in Linux, Python, and the likes. So please like, subscribe, share. All right, so let's get to our business of the day. Let's talk about NAT for IPv4. NAT basically means network address translation. Network address translation. Okay. So we are going to have the following as objectives for our study, and as we go through these objectives, I'll take you through the purpose and functions of NAT. We'll explain the operations of different types of NAT. Then we look at the advantages and disadvantages. Then we look at the three types of NAT, which is static NAT. We'll configure it using the Cisco CLI, the dynamic NAT, and finally the part, which is port address translation, otherwise known as NAT overload. And finally, we look at NAT for IPv6. So this is a very, very important concept, and I'm also going to take you through most of the configurations. I'll take you through a couple of them so that you know exactly how does each type operate. So we start by the characteristics of NAT. Now, NAT is commonly implemented using private IP version 4 addresses, all right? And this is because the world has run out of the public IPv4 addresses. And so what happens is that currently, the few public IPs available are being shared by, just like in every network, we can have 1,000 computers, 500 computers, 10,000 computers using private addresses. But because private addresses cannot be used to route traffic over the internet, we translate those private addresses into just a single or a few public addresses, okay? So private addresses are normally used within a LAN or within the organization's network. And basically, to allow those devices with private addresses to access other devices outside of their network, then their IP addresses must first be translated to a public address. So NAT generally provides the translation from private to public and public back to private. So in this particular table, we have three classes of private addresses. So the first class of private addresses is 10.0.0.0 all the way to 10.255.255.255. That is class A. Class B is 172.16.0.0 all the way to 172.31. So look at the second octet difference. The second octet ranges from 16 to 31. That is very important to note. All right. But the third and the fourth octets range from 0 up to 255. So 172.16, 0.0 to 172.31.255.255. And then the third class is class C, 192.168.0.0 to 191.68.255.255. Very, very important. So these are the three classes of private addresses. And anyone using the internet now, if you can check, for example, I can actually check my command. So let me just let me bring up my PowerShell. So this is my PowerShell. If I say IP config space /o, all right, you realize that my IP address here, my IPv4 address is 192.168.1.1.236, and I'm using a wireless LAN adapter Wi-Fi. I'm using a wireless network here. So you realize my IP starts with 192.168. That is a class, that's a class C address, class C address, okay? But now someone can ask me, how come my PC is having a private IP address? And yet I'm saying a device cannot use a private IP address to access, to route traffic to the internet. And the fact that you can hear me, it means that you are actually able, I'm actually transmitting traffic, routing traffic to the public internet. And that is why I need to explain to you how come we are using this private IP to access the internet. Now, so let me explain further. I want to show you another type of address which I am using. So I'll go to my browser, and on my browser, I will go to a website called myipaddress.com. So when I go to myipaddress.com, what comes here is, you see, I'm told your computer's IP address is 197.155.71.58. And you realize that this IP does not start with 192.168. It doesn't start with 172.16, and it doesn't start with 10 dot something. All right, it starts with 197. Anything that is not starting with 192.168 or 172.16 or 10 dot something is actually a public IP address. So this is my public IP address. This is the IP that has been provided to me by ISP. All right. So the network where I am right now, I can carry up to about 255 users. All right. But anyone in this network will be able basically to only, when they put this website name onto their browser, their phone, their mobile devices, their laptop, all the devices in my network, they will see the same IP address, same public IP address. But when they check their command prompt, or they check their, uh, uh, private IP address, all of them will be seeing something within the range of 192.168. So what happens is that because our ISP is not in a position to provide us every device in the network with a public IP, because they have been depleted, we have a shortage already. What they do is that they give us one public IP, and they tell us to use our internal private IP addresses for the internal addressing. And now all the devices, all the 255 devices, they can share this one IP. All the devices in my network will be able to share only one public IP, right? And so that's where NAT comes in. So NAT, every time any device wants to connect to the internet, they must translate into that one IP, and that is the mystery we need to unwrap that mystery today. How is it that 250, 500, 1,000 PCs using private addresses, how is it that they are able to translate that private into only one public IP? And that is what we are going to talk about today. All right. So like I said, NAT is configured normally within a router. And so from the internal network that uses private IP addresses to the public internet that uses public IPs, A router configured in the NAT will be translating IP addresses on packets from private to public, public to private, private to public, and communication becomes very smooth, and you can't even realize, any interruption in services. And so, talking about NAT, the primary use of NAT, by the way, is to just conserve the few public IP addresses that we have. Honestly, there are very few. And so we have to find a way of conserving them. So NAT allows these networks to use private IP addresses internally and translate them to public addresses wherever needed. Okay. So NAT is normally configured on an edge router. That is the router at the border between our network and the service provider's network. Okay. So that is the work of NAT. Now, there are 4 terms that we need to learn for us to understand NAT. We need to understand these 4 terms. The first one is called the inside local address, inside global address, outside local address, and outside global. So you realize that 2 addresses are having inside. So inside local, inside global. Then we have outside local and outside global. So I'm going to divide this into 2 parts here. Network here. And so here, this is the inside part of the network. If you want to know it is the inside part of the network, this is where we have private IP addresses. This is the outside part of the network. We have public IP addresses here. 209.165.201.1. Now, so inside here also, apart from being the inside network, and this other side being the outside network, this is the local network. Okay, where we have the private IPs. This is the local network. And this is the global network. The global network is the public internet network where we find the public IPs. So that when I talk about inside local, all right, when I talk about an inside local address, it is the inside address as seen from the inside part of the network, as seen locally. Inside address as seen locally, all right? Then I talk about the inside global address. This is now the inside address, but as seen globally, all right? This is our address as seen from the outside. The same address as seen from the outside. What does that mean? That means that people on the global network or outside network, the way they see the private the local address is not the way people in the local network see it. All right. So people in the inside network see 192.168.10.10, but people in the outside network or the global network, they see this local address after it has been translated. The same address, but they see it after it has been translated. So it is always translated to the inside global, which is 209.165.200.226. All right. So, the private addresses, they cannot be seen beyond this particular router. This is our NAT router, and this is where translation takes place. So beyond this router, we see the translated version of the private address, which must be a public address, which is 209.165.200.226. All right. So that is something I need you to note. So inside local is the one before translation, the private. Inside global is the one after translation. Is our address, the local address, are seen from the outside. Now, the outside local and outside global, the address will always be the same, which means the outside local address refers to their address, an address in the outside network as seen from the inside part of the network. In the inside part of the network, the way they see the address of a device in the global is the same way the device, the IP is seen on the outside of the network. All right. So this address, it is seen the same on the outside network and even on the inside network. It is the same. But our private address, the way it is seen in the local network and the global network is different. So this address will always be the same because it is seen the same way, whether you are on the inside network or on the outside network. So that's why outside local will always be the same as outside global, because the address is not translated in any way. But the inside local, when it is seen from the outside, it will always be the inside global because it is seen after translation. So those are 4 terms, very, very important for us to note. So the 4 terminologies. Let's talk about the types of NAT. 3 types of NAT. 3 types of NAT. The first one is called static NAT. Static NAT. The static NAT uses a one-to-one mapping of one private and one public, or one local and one global. All right. So this one is configured by you, the network administrator. So you map one private address and one public address. Let me make that very easier for you guys to understand. So let's say we have these 3 devices here. We have a server 1 at 192.168.10.10, PC2 192.168.10.11, and PC3 192.168.10.12. All right. So we have the same way. We have 3 public IP addresses here: 209.165, 200.226. We have 200.227 and 200.228. Okay. So what we do, we want to map. We want to pair them so that the server at 192.168.10.10, every time it wants to communicate to any device within the internet, okay, we are going to tell this router R2, which is our NAT router, to always translate this 10.10 to 200.226. So we map them so that the server, it will always translate the NAT router will always translate 10.10 to 200.226 as its own public address, and that is not shared. Okay, 10.11 for PC2, wherever it's visiting the internet, it must use 200.227, and it must not change, and it is shared amongst them. 10.12 will always be translated to 200.228. Okay, and so that's why we call them static NAT. Those address mappings remain static within R2. All right. Now you realize if you had 500 PCs, do you realize that you will need 500 public IPs? And you know the challenge we are having? We are having a challenge of having every PC having its own public IP. We are having that serious challenge. And that's why this method is not very viable. Why is it not viable? Because this static NAT, it requires us to have enough public addresses available for the total number of sessions that the network has. So every PC must configure with its own public IP, but we don't have enough public IPs because in most cases, every network normally has just one public IP. It's very rare to find like a network having 2 or 3 or 4 public IPs. It's always one. So this method is not very viable, and we will learn how to configure it, but it doesn't take into consideration the exhaustion of the IP addresses we currently have. Let's talk about another one called dynamic NAT. Now, in dynamic NAT here, we now have a pool of addresses. Okay, we have a pool of public IPs. Might not be many. Maybe we just have 5 of them. We have 5 addresses within the pool. Okay, so let's say these are our 5 public IPs: 200.226, the 227, the 228, the 229, the 230. That is our 5 public IPs. So we create a pool of 5 addresses. Now, the way dynamic NAT works is that out of this pool of 5 public IPs, we are going to be using them on a first come, first served basis. Okay, first come, first served basis, which means PC3 has 10 to 12. Wherever PC3 wants to access the internet, it will pick randomly. So let's say it picks 200.226, the first public IP. Okay. Then 10.11 comes and picks 200.227. 10.10 comes and picks 200.228. And then let's say we have 10 more PCs that needs to access the internet. All right. So if you had 10 more PCs, but we only have 5 public IPs, which means only 5 PCs can communicate to the internet simultaneously. If we had more than 5, let's say we have 10, it means the other 5 computers, they'll have to wait until the sessions of the first 5 devices have been terminated. So what are we talking about here? We are saying that even this dynamic method still requires us to have enough public IPs so that we can have as many PCs simultaneously accessing the internet. Okay, so even this method, it still requires us to have enough addresses available in the pool to certify the total number of simultaneous user sessions. So I have seen very few networks that use dynamic. Now, most networks will always go for the third method, which is called port address translation. Port address translation, otherwise known as NAT overload. NAT overload. Why is it called NAT overload? Because we are going to overload one public IP with so many private addresses. All right. And I want to show you exactly how that happens. That happens. So looking at this diagram here, of course, we have an inside network here, and we have an outside network here. So PC1 has an IP address of 192.168.10.10. PC2 has an IP address of 192.168.10.11. Now, PC1 wants to visit server 1, which is at 209.165.201.1. PC2 at 10.11 wants to visit server 2 at 209.165.202.129 on a different network. So what happens is that there's only one public IP that these two PCs can be translated into. In most cases, that public IP will always be the IP address assigned to this interface. And from what we can see here, that IP is 209.165.200.226. 200.226. And you can see it's the same for both PC1 and PC2. Now let me explain to you how does it happen. So this method uses a concept of the port numbers. We had learned about port numbers before. And so the PCs will generate some random port numbers, the operating systems. And we had talked about something called a socket. A socket is a combination between an IP and a port number separated by a colon. So PC1 will start its session. It wants to visit server 1. Server 1 is at 209.165.201.1. Then there's a colon there. Server 1 is also having port 80. And when you see port 80, that means server 1 is a web server and it's going to use HTTP. Now, server 2 is at 209.165.202.129. And we are also going to visit port 80 on that server. It means we're going to visit web services there. Now, look at this. 192.168.10.11 which is for PC1. It is going to generate a unique port number, a random port number, 1555. Okay, as it's going to be visited. So look at this. When the IP, the packet reaches the NAT router, which is R2,
the private IP is going to be translated into a public IP, but the port number is going to remain the same. You see that? So 1555 is the source port number. It is going to remain, but the IP is going to change from private to public. That is for PC1. For PC2, which is at 116.10.11, here, and the generated port number is 1331, the private IP is going to be translated into public IP, but the port number is going to remain to be the same. It's going to remain the same, 1331. All right. So then once they are translated into the public IP, the source port numbers remain the same. Then they are going to visit the servers. Now, as traffic will be coming back from the servers, so that now server 1 will be sending traffic back to PC1, server 2 back to PC2. So for server 1, source IP will be that of server 1, 209.165.1.1, because traffic is now moving from the server going to PC1. So the source IP is that of the server 1, 209.165.1.1, and the source port is 80, which means HTTP services or web services. And traffic is going to be going to PC1, but from the server, traffic must be sent to the IP address, the public IP first, which is the same IP. You can see all of them, these IPs, just 200 or 226. Okay, so when that traffic reaches the router interface here, and it's saying that the destination IP is 209.165.200.226, and the port number is 1555, the NAT router, again, is going to translate the public IP back to private, 192.168.10.10. For server 2, it will also send traffic to the router interface here, and it's going to the same IP, 209.165.200.226. The only thing that will differentiate the two types of traffic, very important, is the port numbers. Okay, one will go to port number 1555, another is 1331. When it reaches the NAT router translates that public IP back to private, 192.168.10.11, and the port number, of course, is 1331 or 1331, and that's how traffic will be moving. And you can have up to 1,000, 10,000 PCs translating their private IPs into just one single public IP. And what makes the distinction is the port number, and that's why this method is called port address translation, PAT. Port address translation. So translation happens at the level of the port server. So the port is going to differentiate, one PC from the other PC, and that is very, very important. Someone can ask me, what if the two PCs generate the same port number? Let's say each of the two PCs generate 1555. So if the two PCs generate the same port number, okay, so what will happen is that the PCs are going, the first PC will translate its private IP to the public IP at 1555. Now the second PC, of course, it will also be having 1555. Okay, so when the port is translated, the second or the next device having the same port number is going to increment that port number by 1, so that the PC2 is now going to have 1556 here, just to give a distinction between the two of them. And the routers, I mean the PCs, this equipment, hey, they are members of the same family, and they know how to conduct their business. If by any case, which is always very rare, they generate the same port number, then the first device will pick the original port number. The next device will increase it by 1, so that it will be 1556, so that there's no confusion within the network. Okay. Elsie, do you have any question for me?
to ask your your one of to see how this now.
Okay. Okay. Thank you. Thank you. All right. So let's learn some advantages and disadvantages of NAT. So first and foremost, NAT is used to conserve the public IP addresses. You know, the public IP addresses are the legally registered addresses. All right. NAT also conserves the addresses through what is called port level multiplexing. That's when, you know, we are having translations at the very level of the port numbers, where we can have one public IP being shared by so many private addresses. So that is that. Okay. Then NAT increases the flexibility of connections to public internet. So we can have so many PCs using just one public IP, and that flexibility is very great. Consistency for internal network addressing schemes. We can have our private addresses, but they're connecting to the internet. They're connecting to the internet using just one public IP. So there's that consistency that we're having for internal network addressing scheme. All right. Now it allows the existing IPv4 addresses to remain while allowing for change to a new public IP. What do we mean? You need to change your ISP from one ISP to the next, to another ISP. You will not interfere with the private addresses. You just need to change your public IP, and the private ones will remain the same. As a layer of security, NAT will always hide the private addresses from the public, because the private addresses, they cannot be used to reach, to access the internet, because they need to be translated. So what I mean is, from a private address, you can never ping another private address in a different network. It's not easy, because the private addresses are always hidden. Some drawbacks for NAT increases delays. You know, the process of translation from public to private and vice versa causes some delays, and we will be learning that some applications are not very comfortable with it. Of course, end-to-end addressing and end-to-end traceability is lost. You know, when you're connecting, you want to access another device in another LAN or another network, the addressing is, that end-to-end addressing is lost, because there's always private to public, then public to another private the other side, and that loses the end-to-end addressing, you know, for devices in different network. And that means you're not able to ping, you're not able even to trace private addresses in another network. You cannot use traceat or tracer to do that. Like I told you, NAT complicates the use of some protocols and tunnels, like the IP security VPN has issues with NAT. Now, we know that TCP requires the TCP three-way handshake. So services that require the initiation of TCP connections from the outside of the network, or even UDP, some of those can get disrupted during the translation process, and that's why there are disadvantages. These are some of the disadvantages that we have with NAT. How do you configure static NAT? It's very easy to configure static NAT. Okay. Remember, static NAT is one private and one public. Okay. So here are the commands. You say IP NAT inside source static. IP NAT inside source static. Then put your private IP here, put a space, and then put your public IP. So 192.168.10.254 space 209.165.201.5. All right. So that is how we configure static NAT. Just like we said in the access control list topic, by configuring this command, NAT does not take effect until you place it on an interface. And that's why you need to check all your interfaces look for interfaces that are using private addresses or interfaces connected to a LAN somewhere. All those interfaces, you go to that interface. Of course, it will already be having some IP addressing. You say IP NAT inside, and the address that goes to the internet, of course, having public IP addresses there, you use this command IP NAT outside. So IP NAT inside, IP NAT outside. So this is for static NAT. It's very easy to configure. And a static NAT, by the way, it does not have any access control list. We are going to see that in dynamic NAT, we will now be having some access control list configured. There's two commands that we use to verify a NAT. The first one is show IP NAT translations, show IP NAT translations. And the second one is show IP NAT statistics. We'll be seeing that. So we can see that when you say show IP NAT translations, obviously you are able to see the four terms. And inside global, inside local, outside local, and outside global. And like I said, outside local and outside global are always the same. But inside local is the one that is always translated to inside global. So those are the ones that get translated there. Of course, the other command is show IP NAT statistics. Show IP NAT statistics. So show IP NAT statistics is always it's always one where okay, it's always the one where we are we're able to learn the statistics that are available there. All right. All right. So that is show IP NAT statistics. You'd be able to see the inside local, inside, outside interfaces, and even inside interfaces, and how many translations have actually taken place. And you can always clear the statistics, just saying show IP NAT statistics. Clear IP NAT statistics. How do you configure dynamic NAT? Dynamic NAT. So you need to do three things, actually four things. The first one, you need to create a pool of addresses. Create a pool of addresses, and then the second part, you need to create an access control list. Create an access control list, and then the third one, you need to bind the access list to the pool. Bind that access list to the NAT pool, and then finally, you need to indicate your IP NAT inside and IP NAT outside command. So let's see this. So how do we define the pool? Very clear. You say IP NAT pool, IP NAT pool. Then you put, of course, the name of the pool, preferably in capital letters normally. So you say IP NAT pool, NAT hyphen pool 1. Okay. Then you define how many public IPs do you want to be in the pool. So the pool should have 209.165.200.226. Put a space and then put 209.165.200.240. So from the 226 to 240, that's about 15 addresses in this pool. Then you say net mask, then you put the subnet mask. So you have already defined the pool. The name of the pool is NAT pool 1. You say IP NAT pool, put the name, then put the addresses, starting IP and the ending IP, then say net mask, and then you put the subnet mask. Then now we create the access control list. We say access list 1 permit 192.168.0.0. Then you put the wildcard mask here 0.0.255.255. Then now the third step is we bind the pool and the access control list. You say IP NAT inside, source is list 1. This list is the access list, 1, source list 1, pool, and then you put the name of the pool, NAT pool 1, put it here. All right. So IP NAT pool, sorry, IP NAT inside, source is list 1, pool is not. Why are we using access control list? We're using the access control list so that only members of this network 192.168 should be permitted. Okay, the traffic should match exactly any IP starting the 192.168. It doesn't matter what is in the second octet, the third octet, and the fourth octet, because those ones will be ignored, but it should match the first 2 octets as they are. Okay, so that any IP of 172.16 will not be permitted to be translated using this pool. So this access list is to protect this pool to only translate to addresses within this particular range. Okay. Then the last step, of course, is to put them on an interface. You say IP NAT inside on the inside interface, and the IP NAT outside on the interface facing outside part of the network. Yeah. So that is important. I'm just trying to change my network here to. All right, that's good. All right. So that is for dynamic NAT. And then I want us to look at the final one, which is PAT. So we have two forms of PAT. We have NAT that uses only one address and NAT that can use, sorry. Okay. Yeah. We have NAT that uses only one IP address configured on an interface, and we have one where PAT is using only like a couple of addresses put in a pool. So I want us to start with the one in a pool, and then you come back to the one on an interface. So the one in the pool is actually very similar to dynamic NAT. All right. In that, you first create the pool, say IP NAT pool. The name of the pool is NAT pool 2. Do not put any spaces in the names. If you now must put a space, use an underscore or a hyphen. So IP NAT pool 2. The starting IP is 209.165.200.226, and the ending IP is 209.165.200.240, 15 of them. Then you say net mask and you put the subnet mask. As usual, create the access control list. Access list 1, permit 192.168.0.0, and the wildcard mask is 0.0, 255 after 255. Then you bind the pool to the access control list, say IP NAT inside, source list 1, pool, and put the name of the pool. The only difference is adding the word overload. The moment you add overload after the pool, then this becomes PAT, not dynamic NAT anymore. Okay, so the word overload is very, very powerful here. It changes dynamic NAT to PAT. And then, of course, the interfaces, IP NAT inside, IP NAT outside. So that is basically that. Now, if you only have one IP address, and I'll be able to show you that, and that IP is configured on one of the interfaces where you need all IPs to be translated into that IP. So you say you need to create, of course, your access control. You say access list 1, permit this network, and you put the wildcard mask. Then you say IP NAT inside source list 1, access list 1, interface. Then you put the, if it is serial 0/1/0, or it is gigabit Ethernet or G0/0/0, put that interface, the interface that faces the internet part of the network or the public internet, and then you add the word overload here. So the word overload is very, very powerful here. All right. And the rest is the same: IP NAT inside, IP NAT outside. So what I want us to do at this particular moment is I actually want us to do some of those configurations right now. Okay. I want us to do a configurations for NAT static, dynamic, and part. This is what I was trying to explain to you the other time. This is where two PCs, okay, or a PC generates port number 1444, okay, and or two sessions, let's say two sessions, because the port numbers are generated on a per session. What do I mean by a session? What I mean by a session is you're on your browser and you open two tabs. One tab you're on YouTube, another tab you are on Facebook, another tab you're on netacad.com, so on and so forth. So if two sessions, if a session generates 1444 to the internet, okay, or they could be different sessions. So one generates 1444, 10.0 generates 1444, and 11.10. So 10.10 generates 1444, and 11.10 also generates 1444. So these are going to be translated. When we are translating them into public IPs, we'll have to convert the port numbers from 1444. Okay, 1444 will be translated. The first device will take the original port number 1444. The second one will actually take the next one, which is 1445. So that is a very, very common thing that normally happens, but the devices are able to sort it out. Okay. Now, let me talk about very briefly about NAT 64. This is NAT for IPv6. And I need you to note that IPv6 was not developed with the intention of making NAT to translate its addresses. No, because IPv6 does not have a shortage of addresses, okay? But IPv4 has had that session, and that's why we have been having IPv4 having to translate from private to public and public back to private, public back to private, and that is very, very important. IPv6 has an address called the unique local addresses, which has some similarity with the private IPv4 addresses, but the use is actually very different. Okay. The unique local addresses, they're not meant to provide any additional IPv6 number of addresses or address space, and they are also not used to provide any kind of security. Okay. So IPv6 has some level of port address translation or protocol translation, but what it basically does is that it helps in the transition from IPv4 to IPv6. So it is normally used to translate IPv4 networks to IPv6 only networks and vice versa. Okay, and this is a very temporary process in helping the migration from version 4 to version 6, so that those networks that are still IPv4 only, they can communicate to networks that are IPv6 only. Okay, and this will be very temporarily present, but after some time, of course, the migration will be done. Now, at this point in time, I want to work on some few packet trace activities here. Let me check. This is 645, 656, 667, and 66. All right. Let me start with this one here. This is a packet trace activity that needs us to do a few things here. So they're telling us to switch to translation mode. So I'm gonna switch to translation mode, and they want me to from PC1 or L1, either of these two. They need to use the web browser to attempt to connect to the server. So Let me click L1, use the web browser. All right, browser is just loading, and they want me to connect to the server at then I need to type 172.16.16.1, right? And then I need to sorry. Yes, so let me bring up this. So I need to go here, and I was told I can click fast forward. Okay. Yes, and you can see some packets moving here. Use the web browser to attempt to connect. Okay. I need to do what? From PC on, use the web browser to attempt to connect. Wait, okay. Okay, let me just see what I'm able to do here. I need to attempt to. Okay. So let me just see this. Okay. Yeah, I need to have go. Yeah, I'm told the packet should fail, and that's exactly what happened. And I think the next thing I need to do is they're telling me to switch away from simulation mode, and they need to do it from PC1. I need to ping an IP address, and that is ping 49.165.201.2, and here it is. The pings are successful. So these devices are not able to reach the server, but they are able to reach the R1 serial 00, which is okay. They want me to view the routing table of R1. I need to go to R1 very fast. Go to the privilege exec mode, and need to say show run. I need to pipe it to include NAT. No. Yeah. Good NAT. There's nothing on the routing table. Okay. So if I say the routing table does not have entries, I need to say show IP NAT translations. There's still no translations have taken place. So now I need to configure NAT. So I'm told here very fast to create a static NAT translation to map server 1 inside address to its outside address. So I'm given the commands here. So I need to say IP NAT inside. So static. Okay. So mapping 172.16.16.1. I map it to a public IP of 64.100.50.1. So I'm mapping one public IP to a private IP. So I'm configuring R1
so that it's always translating this private to this public within the NAT. Okay, so I press enter. What did I do? Oh, I need to say so IP NAT inside source static 172.16.16.1. The IP is 64.100.50.1. Okay, then I need to do my G00 as inside, IP-NAT inside. So checking at my router, obviously this side is the outside network and this side is the inside network. So what I do, interface G00, let's say int G0/0, enter, say IP-NAT inside, okay? IP-NAT inside, and then interface serial 000. So int S0/0/0 will be IP-NAT outside, okay? And that is all that they needed me to do. And now if I test, I need to test that how the PC can access the server. That's what they're telling me here. Open a command prompt on PC1, or let me open a command prompt on PC1. And now I need to do what? I need to ping the public IP address of the server. So ping 64.100.50.1, and we should get some feedback here. And see we are getting feedback. We're getting replies there. We're getting reply. That's very good. And then we need to verify that PC can now access the server. So I can go to the server web browser of this PC. And now I can access the server web page. And the web page will be 172.16.16.1. Okay. And I should now be able to access the server. Okay. Okay. I could just yeah, it's a timeout, I think. Let me do the 64.100.50.1. Okay. Yeah, you can see we're able to actually reach the server here. Welcome to server 1. So that's all they needed us to do here. We can now look at some translations here. You say show IP-NAT translations. Okay. And you should be able to see some translations that have been done already here. You can see 64.100.50.1.80. That is our inside global. It was translated from 170.16.16.1 at port 80, and the outside local are actually here. Okay, very, very important. And you could even see the statistics, show IP NAT statistics, and there are some statistics here. 2 translations have taken place. There's one static and there's one dynamic. The outside interface is serial 000, and the inside interface is gigabit Ethernet 0/0. 14 hints and 9 have been missed so far, and 8 are expired translations, of course, right? So that was a very simple one. That was a very simple one. Probably we can attempt another one, and you see we scored 100% rate here. We could try a simple one, another one. Let me see if I can try another one here. That is the one we did.
there's one here, one for configuring dynamic NAT. This is for dynamic NAT. I can leave you guys to do that, but I can do the one that requires us to have. Let me see this one. This one requires us to configure some overload stuff here. Yeah, so let's work on a 667. Okay, this is 667. And for this one here, we need to configure traffic that will be permitted. Okay, so they told us configure on R1, configure one statement for CL to permit any address belonging to 170.16.0.0/16. So we go to R1 right here, and in R1 we need to go to the global configuration mode, and we need to create an access control. So access list, and list is list 1. We are permitting 172.16.0.0, which means any address starting with 172.16. It doesn't matter what follows on the third and fourth octets. So wildcard mask is 0.0.255.255. So that access list is created. We need to create a pool on R1 that is just 2 usable addresses in network 209.165.200.232. We say IP NAT pool. Sorry, IP NAT pool. The name of the pool is okay. Name of the pool is any underscore pool underscore name. Okay, any pool name. Okay, and then put 209.165.200.233. That is the starting IP. Then the ending IP is 209.165.200.234. Okay. Then you say net mask, and you say net mask, we put 255.255.5.252. That is /30. Okay. So IP NAT pool. Then the name of the pool is any pool name. I don't know whether this is the name or they want us to change the name. They didn't tell us. Okay. Right. Then you just need to enter second, creating the pool. Then you now need to bind the pool to the SCL. Normally just say IP NAT inside. IP NAT inside source list, and the list is 1 pool, and the name of the pool was any underscore pool name. That was the name of our pool, and that is okay. Then we need to go to looking at this interface of R1. The only interface that goes to the internet, that will be the public, that will be IP NAT outside. Otherwise, G00 and G01 are all going to be IP NAT inside. You say interface G0/0/0. You say IP NAT inside. Okay. Then you say interface G0/1. You say IP NAT inside, but interface S0/1/0. That is going to be our IP NAT outside. IP NAT outside. Very good. Then once we do that, we now need to verify dynamic NAT with overload implementations. Okay. So you're told from the web browser of each of the PCs that use PR1 as the gateway, access the web page for server 1. Where is server 1? All right, so we need to get to any of those PCs So I need to go to PC1, go to the web browser. It's just opening the browser now. Give it a few seconds and it's there. So write 209.165.201.5. Server 1, correct. Let me try from probably a laptop on the second interface, and I go to the browser and I try to access the server as well. All right, the PC is just opening. So 209.165.201.5. At 5, and you can see server 1. Welcome to server 1. That means they're all accessible. Let's try, because they said from each of them. So I try to this PCs here on PC L1. For PC L1, put the IP address for the server 209.165.5. 209.165.5. I can see that two PCs are not going through. Yeah, this is giving us a request timeout. I don't know why. Okay, let me do it again. PC L1. So 209.165.201.5. This doesn't seem to be going through. I need to try it on PC2 as well. It's timing out. PCB, PC2. I go to the browser. Let me try if it's going to go through before we move on with the instructions here. We're going to do IP NAT translations to view that. So 209.165.201.5. And this doesn't seem to go through as well. So therefore yeah, there's a problem there. So let's listen to what they're saying here, that so all connections are not successful because L1 and PC2 are not going through. So what we need to do, we need to say show IP NAT translations on R1. So we can open this wider. So say, should you show IP NAT translation? And we can see some translations here that happened for the two successful ones. We were having from 17.16, 10.10, and 10.11. They were translated successfully into 209.165.200.223 and 234, but two are not translated. If you say show IP NAT stats statistics, we can actually be able to verify that there are some misses. There are some 38 misses and 15 hits. Okay, but the details of the pool, of course, are here. Pool name, access control list, the starting IP and the end IP. Total addresses in the pool is here. Misses were 6. Yeah, so all of those details, of course, well explained there. Then we are told that notice that all 4 devices can communicate. They're using just one address out of the pool. Part will continue to use the same address until it runs out of the port allocated associated with the translations. Once this occur, the next address in the pool will be used, while the theoretical limit will be
65,536. Since the port number field is 16-bit number, the device will likely run out of memory before that limit will be reached. So they're trying to say it's not possible for us to run out of the stations because of the 65,536 theoretical limit for translations. So we need to configure now part using an interface. Okay. So we are told configure traffic that will be permitted. So on R2, we configure one statement for SCL2 to permit any address belonging to that one. So let's go to R2. So in R2, we go to the global config mode. To create an access list, we say access-list is 1 permit, and you're going to permit 172.16. Sorry, 172.17.0.0. The wildcard mask is 0.0.255.255 as our wildcard mask. So that is done. 172.17.0.0. All right. Then we have to associate the SCL with the NAT interface and allow addresses to be trusted. So enter R2 NAT statement to use the interface connect to the internet and provide translation. So what we're going to do, we're going to make sure that this interface here, S011, all traffic from these two networks are going to be translated on this interface. Only on the IP address on that interface, which is actually 219.165.202.128. So we just need to say IP NAT inside source static source list. Oh, we did a mistake here. The access list should be, we need to remove this one. We need to say no SCL, and we need to say access list 2, not 1. Thank you for that. So we need to say IP NAT inside, IP NAT inside. Source should be list 2. Okay, and all of them must be translated on the interface S0/1/1. Okay, and you need to overload it. You need to overload it. So all interfaces, all IP addresses from or all devices on this network, packets sent through this interface to the internet will have to be translated. The private address will be translated to the IP address of this interface there, S011. We need to configure the interfaces to the appropriate inside and outside commands. Okay, so very simple. We have G00 IP NAT inside, G01 IP NAT inside, and this is the only one that's going to be IP NAT outside. So we say int G0/0/0 IP NAT, IP NAT inside. Good. Interface G001, we say IP NAT inside as well. Then we say interface S0/1/1, you say IP NAT outside, and that is actually done. I know it is hit 100% already, but we can be able to verify that. So from the web browser of each device of PCs that use R2 as the gateway, that is PC3, L3, PC4, L4, use the web to access the server. Okay, so let's try that. We want to access the server 209.165, so I go to PC3, and I need to go to the web browser. Browsers are opening a bit slowly here. Okay.
So just need to go to the server 219.165.201.5 and welcome to the server. That's pretty well. L3. I want to go to the browser, web browser, and I'm going to access the server. Server takes a few seconds to open up, but after it opens up, that will be okay. Okay, the server is here. So 209.165.201.5. Welcome to the server. That's good. PC4. PC4 is here. Let me open the web browser. Let me open the web browser and see if that's going to work. If we can do L4, and I think then we'll view the NAT translations. Right, so 209.165.201.5. So welcome to the server. That's perfectly well. L4. Your packet tracer is heavy, guys, and that's why it takes a little bit of time to open, but it will open anyway. But then we view the translations on PC on R2, and then we compare NAT statistics on R1 and R2. Okay. Okay, so 209.165.201.5. Server, welcome to server 1. Let me look at the translations here. So I can do Control Z and let's say show IP NAT translations, and you can see a forest of translations here. You can see a whole bunch of translations here. Look at this, all these devices from 10.11, 10.10, 11.10, 11.11, all the 4 PCs, their IPs have been translated to the same inside global address. 100.130, which is the IP address. This was the IP address of the IP address of this interface here. Okay, yeah, that was 209.202. I mean 209.165.202.130. All those PCs are being translated because we're using PAT here, port address translations. The port numbers, look at the port numbers were initially the same, but they keep on taking the previous ones. So this has taken 1024, 1025, 1026, 1027. Very important for us to be noting. Okay. So I think that is good to go. Probably we could do just one more before we get going. I don't know whether this is a good one to be done. Yeah, probably we could do work on this very fast. This is a very short one. To configure NAT, and we are told that this lab will configure a router with dynamic NAT with PAT, and this will translate the addresses from 3 internal LANs to a single outside address. In addition, we'll configure static NAT to translate an internal server address to an outside address. Okay, so we'll configure dynamic NAT with PAT and then static NAT. So they told us to we're going to do them on R2. And so we go to the CLI and go to the global configuration mode. And what we do, we're going to use an SCL to permit addresses from LAN 1, LAN 2, a named SCL. So we say IP access list, and the name is R2 NAT. Okay.
Oh, wait. IP access list R2 NAT. Sorry, IP access list. Now, because it is telling us to permit addresses from only one device, and it doesn't tell us to where, to the destination, it means this is going to be a standard. This is going to be a standard access list, and you put the name R2 R2 NAT. It's a standard access list because it only tells us the source of the traffic. It doesn't tell us the destination. So that is that. Then we want to permit 3 networks. So we are going to permit these 3 networks here. So you'll permit LAN 1 here, LAN 2, and LAN 3. Okay. So let's start with the LAN 1. Say permit 192.168.10.0. The wildcard mask is 0.0.0.255. Okay, the 255 is there. Enter, and you need to do them in order. Start from LAN 1, you go to LAN 2. You say permit 192.168.20.0. Wildcard mask is 0.0.0.255. That's done. Then LAN 3. Permit 192.168.30.0. Wildcard mask 0.0.0.255, and that is done. Okay. Also, we permit 3 networks. We now need to create a NAT pool named R2 pool. So we exit from the access list configuration and say IP NAT pool, and we say the name of the pool is R2 pool. R2 pool. Then the pool should use the first address on that network. So we have 209. When you're given only one address to put in a pool, it becomes the starting and the ending. So 291.65.2.129. That is the first address because the network is 128. So the first usable is 129. Then you just put it to be the ending IP 209.165.202.129. Okay. You say NAT mask. Then you say subnet mask is /30, so that is 255.255.252, and that is done. Then we need to then you need to configure NAT with SCL and NAT pool that you have created. So you say IP NAT inside. Source is list, and the name of the list was R2 NAT. Okay. And then pool should be R2 pool. Now, I want to see if I add the word overload here, what's going to happen. And I press enter, I get 37. If I remove the word overload, because they have not told us to put on the key instruction, yeah, they have not told us to exclude the overload. So I put overload there, and then we're told to configure static NAT. Okay, say IP NAT inside source static. Okay, then I need to put the second address of that network will be 130, but they are also provided right here. Just remove this. Yeah, those addresses are actually provided up here. So
static. So 192.168.20.254. That is a static. That is a private IP, because this is now static. One private, one public. So the public will be 209.165.202.130. Okay, it's done. Then the next thing we need to do is to place them on the interfaces. So we need to just do that. We need to say show IP interface brief. So we have 4 interfaces from what you can see on the diagram. There are 4 interfaces. The first interface is actually first Ethernet 0/0, the one going to the LAN 2. Then we have 0/0/0/0, the one going to 10.1112. So the one going to LAN 3, sorry, LAN 2. Then 10.2.2.2, 0.0.0.1, the one going to LAN 3 here. And then we have the only interface 0.0.1/0, the one going to the internet, which is the only one going to be IPNAT outside. So first Ethernet 0/0, IPNAT inside, 0.0/0/0, IPNAT inside, 0.0/0/1, IPNAT inside, and then 0.0/1/0, IPNAT outside. So let's do that very, very fast. So interface F0/0, say IPNAT inside, interface S0/0/0, IPNAT inside, serial 0/0/1, IPNAT inside, and then serial interface S0/1/0, we say IPNAT outside, IPNAT outside, and that's how basically we get to do it. So what we can do is to see if it's really working. All of them will be translated to the same IP. All of us can actually be pinging the Cisco.pka. So let me go to this PC and go to the desktop and go to the command prompt. Let me ping Cisco.pka, Cisco.pka. That will be pinging that. Let me see if I don't do it through the browser, if DNS is going to be working here. Let me fast track this one. Wow, it was able to go through. Yeah, there we go, receiving the replies. Let me try from this piece, from the server here. Go to the desktop and I want to ping Cisco.pka and see replies coming. I'm pinging the domain name of the server there. Let me ping from LAN 3, and this time around I go to the browser. I have a little bit of wasting of time here, but we are good. I go Cisco.pka, and there we go. Welcome to the server. So what do I need to do? Let me check at show IPNAT translations. You have a couple of translations here. Look at them. So 10.10, we did it, I think, here. We had 10.20.254, 20.254. We had several of them. Those are actually just pings there. Then we had 30.10, and you can see all of them are being translated here. One was being translated to the static one. Then of course we have the dynamic ones as well. Yeah, so very successful. Show IPNAT statistics. There are a couple of statistics here. You can see that the inside interfaces were 3 here, and the only outside interface is here. There are 18 hints that were done, 12 expert translations, and 13 misses were there, of course. And yeah, so far so good. So this is not for you guys, and feel free to meet us during our next class. We'll be talking about one concept for CCNA 3, and we'll also upload that. Otherwise, guys, thank you for your support. Continue subscribing, like and share with your friends, so that you don't have to struggle with the networking concept. You just have to be here, and Alan, the network professor, will be able to profess the networking skills. And look at my previous videos, CCNA1, CCNA2. I've done very, very, very remarkable videos on that as well. Look at subnetting, look at IP addresses, look at IPv6 addressing, look at chapters in CCNA2, look at VLANs, inter-VLAN routing, DHCP, so on and so forth, trunking, and we are going to do this at the end of CCN3. You shouldn't struggle, guys, because there's so much to do. And here we're giving the very best content here, and it's because we really value you and we want to demystify some of these networking concepts. Otherwise, thank you very much, and I'll meet you in our next class. And feel free to to come for more and more content. We are trying to demystify learning of CCNA to be much easier, and very soon I'll be doing even videos on some tips on how to pass your CCNA exam. I'll do videos in SSH, for example, using real devices, and trying to check why do you prefer SSH over Telnet, and what is the benefit of using SSH in connecting to your networks remotely. Otherwise, thank you very much, guys, and I'll see you soon again in our next video. Thank you. Right.